folks, good morning. Before we get started today, YouTube sent me one of those little automated prompts telling me to say something, so I figured I would. At the time of this recording, this channel has passed, I think, 1,300 or something subscribers, which is really exciting. I want to thank you. Thank you for believing in me. Thank you for watching these videos. I hope you find them useful and informative, and hopefully we can go on this learning journey together for many years to come. I think to that end, something that I've been seeing a lot in the comments is people are starting to pick up on these videos and watch them and say, hey, can you teach me about cameras? Hey, can you do one about characters? Can you do one about AI? All of those will come in time. I will try to do videos on most of the topics that are requested. But there's something that we should probably call out first. Making games is really hard, and there's a reason that it takes years to gain proficiency in some of these engines, even when you're working in them day in, day out. Now that you've learned a little bit, you might kind of want to jump in and say, great, okay, I'm going to start making games. And I think that's awesome. I think taking your own teaching into your own hands is a great way to go about this. But if you find yourself in over your head, it's okay. That's normal. One of the reasons that I started creating these videos is that I wanted to give you a sense of not just how to actually use a game engine, but why we use engines in the way that we do and what are the core concepts that we're basing a lot of our work on when we build something in a game engine. If you take the time to focus on learning a few of those fundamentals now, they'll serve you really well, not just in your future career or hobbyist work as a game developer, but also in anything else you do when it comes to computer science-y type things in the future. Speaking of fundamentals, we're going to be covering two topics today. Topic number one is dynamic references, and topic number two is arrays. And then we're going to use an array of dynamic references to build a working elevator that you can use to go up and down. At this point, you're probably like, that was a bunch of word salad. What does any of that mean? Last time we learned that a reference is a way that one game object can reach out and talk to another game object and store information about that second game object so that the first game object can easily contact that second game object whenever it feels like it. Then we actually went into the editor and we assigned a reference. We had your switch get a reference to the door that it was supposed to be paired with so that it could then open the door, right? Well, guess what? In any programming language with any type of program, and yes, that includes games, there are basically two modes that program can exist in. Mode number one is before the program gets run. All of the conditions that are set to be various things, the state of the world, what's going on, what has references to what objects and how, that's what we set up in the editor last time, all before we'd actually even hit play on our game. The second mode is runtime, or at least what we call at runtime. Once we actually hit play on our game, or in the regular programming world, once we actually run the program, anything that happens after that point is called at runtime. So static references are references that we get when we're in editor or before we run the program. And dynamic references are references that we get after the program is already running or at runtime. Let me explain it this way. Remember last time how we talked about the way that a variable is like a shoebox, and that shoebox can either be empty or it can be full of something, aka shoes, which is the value of the variable? Let's continue that metaphor. Let's pretend that we're running an entire shoe store, and that shoe store, which is full of shoe boxes, is basically our game or our program. And let's pretend that the people who are operating and running the store clerks, are our game engine. All the game engine does is follow a list of orders about how to run the shoe store once the shoe store opens for the day. Before the shoe store opens for the day, maybe the clerks have been given some instructions about where important things are in the store in case they need to find them. For example, that pair of rare Nike sneakers is on the left shelf 7 rows up. Let's imagine that the store then opens for the day. This would be runtime. This is when the program starts running. Anytime somebody comes to the front desk and says, hey, I would like to buy that pair of rare Nike sneakers, the clerk can say, well, great, I already have a reference to that. I know that it's 7 rows up on the left, so I actually already have that reference stored. I will go and I will find that box of Nike sneakers and bring that back to you. But, and here's why we use static versus dynamic references, a lot can happen throughout the day at a shoe store. It can be absolute chaos. What if there are hundreds and hundreds of customers? What if somebody sets off a bomb and blows up hundreds of rows of shoes? What if some of the shoes get lost or shuffled, or they're just not where you thought you left them? All of a sudden, now you have customers that are coming and saying, hey, I want to buy a pair of Nike sneakers. And the clerk is saying, I lost the reference. I actually don't know where those sneakers are anymore. Oh my God. Well, guess what? A game world is a lot like a shoe store. Once the player starts actually mucking around in the game world, they can be changing a lot of state at any given time. They could be blowing up walls. They could be, in the case of Minecraft, they're placing hundreds and hundreds of blocks all over the world and destroying them at whim. that world, that game world, is in no way the same game world that it started out as. In other words, the pre-runtime game world and the post-runtime game world are very, very different states to exist in. So being able to get a dynamic reference is really helpful, because what it does is it allows your program at runtime or your game to basically say, okay, I want this thing in the world. I actually don't know where it is right now. The player could have done any number of things with it, but I know how to find it. So I'm going to follow that process to go and find it. And then when I find a reference to that thing, then I can hang on to it in order to do whatever I need with this thing in the world. In other words, writing down a reference to where that pair of Nike sneakers is on the shelf, that's a static reference. A clerk can only go look for the shoes in that one location. But getting a dynamic reference is like teaching your clerk how to find Nike sneakers anywhere in the store if they would like to go find some. So if somebody moves the Nike sneakers to a different shelf, in that first case, the clerk would be out of luck because they only had a static reference. They don't know where to find the sneakers anymore. But in the second case, where the clerk actually knows how to go get a dynamic reference, they can find those sneakers no matter where they are in the store. They're set. Okay, but then that begs the question, how do we train our program to be able to go out and get dynamic references at runtime? In other words, how do we train our clerk to be able to go find shoes anywhere in the store once the store has opened for the day? Well, we can do that by using what's called an array. An array is a data structure that can basically hold a list of references, and it's a concept that exists in every programming language, not just in game engines. Wouldn't it be nice if, in our imaginary shoe store example, every clerk had access to a list of all of the shoe boxes in the store, as well as their given locations at any point in time? If the clerk didn't know where a pair of shoes was, they could just go consult the magic list. They could say, hey, magic list, I'd like to find the pair of white Nikes. Do you know where that is right now? And the list would tell them exactly where to go look for that. Now, imagine we could do all sorts of things with that magic list. If a customer came in and said, hey, just give me the first 5 shoes in the store. I don't care what type they are. We could just go to that magic list and say, hey, give me the 1st through 5th pair of shoes on this list. Bring them out and sell them to the customer and get rid of them. We could delete things from the list. We could say, hey, turns out I actually did a check of the store and this pair of shoes on line 17, that doesn't exist anymore. So I'm going to just remove that from the magic list. And the magic list would collapse to remove that pair of shoes. We could sort the list. We could say, hey, I want to sort the list by color, or I want to sort the list by newest shoes versus oldest shoes, or I want to sort by some other property that is inherent to the shoes, like the color of their laces. An array lets us do all of those kinds of things very easily. So all we're going to build today is a set of switches that are paired randomly with a set of elevators that turn those elevators off and on. So you can get kind of a roguelike-y type room where elevators turn on at random. So let's get into it. Let's open up our project and get started. All right, so here we are back in our main map. The first thing we're going to do, we're actually not going to be using the gates at all for this tutorial. So we are just going to go ahead and if you have any gates around that you left in from the last tutorial, go ahead and just get rid of them. UE4 is going to yell at you because your switch and your door are again linked through a static reference. So if you remember the shoe store metaphor earlier, UE4 is yelling at you because it's like, hey, this will break references. Your clerk will no longer be able to find that pair of Nikes if you delete this list, which points to it. But that's okay because we're actually going to be building dynamic references this time. So let's go ahead and delete those doors. Just let UE4 get mad at you, it's fine. And actually, for the sake of this tutorial, you can also delete these switches here. We're going to be creating a variant of this switch actor and blueprint today, just to do something a little bit different with our elevator logic. So at a high level, here's what we're going to do. We're going to create a new switch blueprint based on the old switch. And all that switch will do is when the player walks on top of it, it's going to find a random elevator that has not yet been turned on and turn that elevator on. And then the elevator is going to move the player up and down. So to start off, we're going to build that elevator itself and just have that ready to go so that when we actually build the switch part of this, we can easily turn the elevator off and on and just see it working. So let's go ahead and right click here. We'll make a new blueprint class. It's an actor and we're going to call it elevator. Awesome. This elevator is going to be based on a lot of the same concepts that we've already used with the door and the switch. It's just going to be, it's not even going to use a trigger volume this time. It's just going to be a cube that's tucked up to a timeline that moves up and down. And because it has collision by default, when your player steps on top of it, they will get moved up and down too. So go ahead and add a component. Let's add a box, cube here. And we're going to name that platform, just so it's nice and easy to find. It's a giant cube right now, so let's smash that down, turn it into a platform. If you want at this point, you can also give it a material. I'll make it yellow because why not? Yellow, that's cool. And then when we zoom out, we should see that it looks like roughly a little cube kind of flat platform here. So now what we want to do is give our elevator a variable. That variable is a Boolean. And that Boolean is going to be called isElevatorActive. It starts false by default because this elevator will not be active by default, although in a second we're going to turn it to true for testing purposes. And what that's going to do is basically allow us on the switch side to randomly loop through the array of all the elevators in the scene and say, hey, if this elevator that I pull out randomly from that array is not yet turned on, then activate it and I have done my job. But for now, we're not actually using that variable yet. So now what we're going to do is we're going to create some custom events for the first time. In an event graph, UV4 gives you several events that are default that just come right out of the box. There's this begin play event, which fires, of course, when the game first starts playing at runtime. There's this begin overlap, which only happens when the actor is overlapped by another actor. And then there's this tick function, which we used last time in order to change the text on top of our door. We're not going to be touching any of those this time. We're going to be making our own special custom events. And the way that we can do that is we will right click ... We're going to add a custom event. And we're going to name that event elevator raise. And then we're going to do that again, create another one called elevator lower. And then we're going to create yet a third event, ... And we're going to call that turn elevator on. Why can't I spell? Turn elevator on. Okay, so here's what we're going to do. The player's going to be able to call this turn elevator on from the switch. And then that turn elevator on is going to call this elevator raise. And then the elevator raise event is going to call the elevator lower event. And the elevator lower event will call the elevator raise event. And then that will be a nice repeating loop that just goes forever. So what do we want to do with this elevator raise? Let's start here. And let's bump these down because we're going to probably need more space. On this elevator raise, all we want to do is play a timeline that basically is hooked up to the relative location of that elevator's position. And we're just going to adjust the Z value of that, just like we did when we made that door slide up and down a couple tutorials earlier. So if you type in timeline here, you can get that add timeline node. Let's call it raise timeline. And we actually want to play that from the start. And if we go in here, we can, again, just like we did with the door, we're going to add a new float track. That float track is just, again, what's called raise elevator value. And because that elevator is starting at the bottom of its raise cycle, it's on the floor, we're going to put the very first key here at 0, 0, because currently, when we start the timeline, the elevator is where we want it, and then we want it to move up. So we are going to set that next key, right click, add key. We're going to put that either, really the time value can be anything. It depends on how slowly you want your elevator to move. It kind of doesn't matter. I'm just going to have it be like a 3-second elevator. And at 3 seconds, that value will be 1. So if you zoom out, you should see something that looks a little bit like this, 0, 0, and 3, 1. You can also, have this be 2 or 4, however long you want that elevator to take. Kind of depends on how far you want it to go. But whatever that time value is, make sure that you clamp the length here from 5 to whatever that length is, just so you don't have a timeline that's running past its actually completed logic. So we'll compile that. We'll back out of that. And then when we go to our event graph, we should see that raise elevator value appears here. Excellent. We love it. Let's drag off a reference to our platform here. And we're going to set relative location on that platform. Again, this is just like we did with the door. So if you find this is going a little bit fast, you can always go revisit the door tutorial and see how we did it there. We're going to right click on this location to split that pin up into its X, Y, and Z values. And then what we're going to do is take this value, which is going to be somewhere between 0 and 1, depending on where the timeline is. And we're going to multiply it by how high we want this elevator to go. So for reference, if we look at this viewport here, and we try and move it, we can actually see over here on the right, there's this like z equals 0. We have this z location value. Just to get a sense of like how much 100 is, you could try kind of scaling it up. Let's see, all the way 99, 100. So that would be 100 units. That's like a reasonable elevator. It's not like super tall, but it'll be okay. Let's just try 100 and see how we go. Keep in mind too that, you know, speed equals distance over time. So if you do not adjust the speed of your timeline and you want your elevator to go very high, it is going to go very fast, maybe too fast for the player to actually make the elevator. So you might want to just slow down the timeline in that case, if you decide to make an elevator that like goes very, very far. But in this case, let's just take that elevator value and we're going to multiply that by 100. Oh, not an int. No. We want a float times a float. So let's make that 100. And on the update, we're going to set the relative location for the platform and just do that with its C. And we should be doing, again, make sure this is relative, not world. The set world location node will be setting its actual location permanently, and it will probably instantly snap to X is 0 and Y is 0, which is like probably some coordinate off in space. Don't do that. Just make sure you're setting its relative location. Once we've actually done that, then on the finish, we want to call elevator lower, because guess what? We're done raising the elevator and now we're going to lower it. On the lower side of things, we're going to do the exact same thing in reverse. So just click, drag, and select all of these nodes, Control C, Control V to copy and paste. And then on our elevator lower, we are going to reverse from the end, just like we did with our door slide earlier. We will, you know, you can rename this timeline if you want to like lower to make it a little bit cleaner. And this platform, once again, we're going to be reversing from end, changing its value by 100, and it should go back to the start. And then, once again, when we have finished lowering our elevator, we will call raise elevator. I love it. Look at that. So what we have here is a loop. When that elevator is done raising, it will lower, and when that elevator is done lowering, it will raise forever. Great. The one problem is that currently we're not calling either of these events ever, so that elevator will do nothing at runtime right now. So we want to make sure that when we actually turn the elevator on, then we call that elevator raise function for the very first time, which then kicks off that infinite loop of the elevator raising and lowering. So let's have that turn elevator on event hooked up. Again, nothing's calling turn elevator on though, so we actually need to like turn it on for the first time. So for now, just to test to make sure that it's working, let's drag it from begin play. So when we begin play, which is at runtime, then we'll turn elevator on, and that should start that repeating loop. So if we go out here to the first person example map and we drag out one of our elevators, let's make it like a little bit fatter and wider, just so it's easier to look at and stand on. Save current, and we hit play. Aha, look at that elevator. It's raising and lowering. And we can actually get on the elevator, and we're raising and lowering. Easy, right? So now let's go back and make sure that we have unhooked that from begin play. Just make sure to remove that so that we're not actually turning the elevator on at the start of runtime anymore, because that's not going to be the behavior that we're looking for here. And make sure that this is elevator active variable. If you haven't made it public already, then go ahead and make that public, because that is how switches are going to find elevators and pair with them dynamically at runtime. So go ahead and compile that and save that. We're looking like we're in a pretty good state here. If you ever want to adjust the height of the elevator or the speed of the elevator, you can come back and do that here. And you should just be able to adjust this little float box here or the length of the timeline here to make that happen. So let's back out. And if we go into our first person example map again, we have this switch here. This switch is like paired to open doors right now, and that's basically all it does. So we probably want to just, for the purposes of this tutorial, create a switch that is like custom fitted to just turn platforms off and on or turn elevators off and on. So let's right click here and we will duplicate this class, this blueprint class. We're going to call it elevator switch. And then actually, just to make it like super, super clear, which type of switch works with which things, you might just want to change the color of that switch to match whatever you did for your elevator. If you did change the color, if you don't have to as well, you could also like add a text component just like we did last time. Text render that just says elevator switch or something like that, so that players know when they experience this switch, oh, this is an elevator switch, it's not a door switch. But so now we've made it yellow to match our beautiful yellow elevator out here. And what we're going to do is go into the event graph here. Right now you can see this has just got some logic that's specific to the door, setting the door value locked. And it's also got a door here. Let's just do some cleanup. Variable my door is in use. That's fine. We're not using it anymore. So let's delete it, clear out all of this as well, and save that switch value. Now we're actually creating the bulk of our logic here. So when the player steps on this switch, aka they collide with the switch collider, we are going to loop through all of the available elevators in the world. We're going to say, let's get all of them. Let's put them all in an array. Let's shuffle that array so it's randomized. And then let's find the first elevator in that array that has not yet been turned on and turn that elevator on. And then we're going to mark it as it has already been turned on so that we don't turn on the same elevator twice in the future, because that would be bad. So let's go here. And when you drag off, we're going to try a new node that we haven't used before, which is get all actors of class. So if we type in get all actors of class, you will see there's a few different utility functions down here. Interfaces, tags, these are advanced concepts we'll cover later. They're really useful to kind of like group a bunch of different types of classes if you are looking for like similar classes but not exactly the same class. Right now we just want this generic get all actors of class node. And that class, of course, is going to be our elevator. Why can't I spell elevator today? There. Great. I love it. I keep trying to spell it Elevator. So what this does is this gets us an out actors. Aha, what is this? An array of elevator object references. Oh, this is our magic list. This is a list of all the shoeboxes in the store and where they're located and information about them. Perfect. So all this does is it gives us a dynamically generated array. So this is an array that was generated after the game started running. So for example, maybe in this game, we give the player the ability to like spawn elevators. I don't know, a game like Portal, for example, you have portals getting spawned and destroyed all the time at the player's whim. So we actually have no idea where these elevators are, how many there are. It kind of doesn't matter. So this blueprint will end up working no matter how many elevators you have in the world. So we've got this array. And now what we want to do is we want to loop through that array. And this is, again, looping if you've never taken any intro to programming course, which may help if you want to understand this in more complexity, but I'll also try and link some videos below this video. You can basically go through every instance of that array, everything that's in that magic list, and for each one, do something. So in this case, we're going to drag off here and type in for each loop. Ooh, and you will see a number of possible different array loop functions here. There's for each loop, which is just the regular for each loop. And then there's for each loop with break. So the difference between a regular loop and a loop with a break is that in the regular loop node, you will go through every instance of something in the array and you will do something on all of them. In the case of the for each loop with break, it's that exact same behavior. However, you can also say, if I found something and I did what I wanted to do with something in that array, then I can actually just stop looping that array any further. I don't want to go any further. I don't want to like consider any of the other indexes in this array. So we are actually going to use that for each loop with break node here. So what we're going to do is for each elevator in our level, we're going to find the first one that has not yet been turned on, turn it on, and then we're going to break the loop so that we're not actually looping through the rest of them unnecessarily. Something worth noting is that every single item in an array is actually called an index. Like the position of that item is called the index. So when you see array index here, this is an integer value. Let's say, for example, you had like 3 shoeboxes on a shelf and you're like, I want to find the second index. You could actually go over and find the right shoebox. Something confusing worth noting, and I will note this here on the video as well. With arrays in every programming language that I personally know of, arrays, the indexes don't start at 1. The first thing in the array is not the first index. The first thing in the array is the 0th index. Why is that the case? I don't know. Programmers. It's it's just kind of standard, but it is a little bit confusing. So just keep that in mind. So for each loop with break, for every elevator, so this is the element that we're looking at. This is like for each one of these, we're going to check the variable. I forget what that variable was called. It was, is elevator active? Here we go. We're going to check, is elevator active? All right, so 4-0, 4-1, 4-2, 4-3. Is an elevator active in the scene? If it is, then let's go ahead and branch here. If the elevator is active, then we want to do nothing. If the elevator is not active, then we would like to turn it on. Great. We already wrote this nifty little turn elevator on function. And then of course, just to make sure that we actually mark this elevator properly, we then want to set is elevator active to be true because we've turned this on now. So we don't want to turn on the same elevator twice. So we want that to be nice and clean. The last thing that we have to do is, of course, once we've done all this, we want to break out of this loop so that we don't like keep going through every single elevator in the loop and turning it on because that's bad. So we are going to drag off this white node. It's going to get real confusing for a sec. Just bear with me here. We're going to drag it all the way to this break here and you will see, oh no, it's this awful white stretched noodle. It's so bad. So let's double click on the noodle. I'll show you a little handy shortcut in UE4. You'll see this little white dot appears. That's a node that you can use to kind of like position the noodle so it doesn't look so strange. If you are hovering your mouse right on top of it, you'll see it's kind of like this crossbar. But if you just move it slightly off within the yellow box, you'll see it turns into this little white crossbar. You can use that to kind of reposition that noodle and make life easier for yourself. You can make a couple of them if you want. That way it's a little bit easier to read and look at. It's not quite so painful. And then, of course, you know, we've gone through our loop. We went until we found the first active elevator, first inactive elevator, rather. We turned it on, set it to be active, and then we broke the loop. So now what we probably want to do is go back out to the scene here. We have this one elevator in here that we dropped in here earlier, but I'm just going to go ahead and like copy paste that 4 times just so we can see this in action. And then we're going to put down a switch that will be used to turn on one of these elevators. Let's make that switch nice and big. So we're probably going to encounter a weird issue here that you're going to notice when we hit play. But let's go ahead and see. We would expect, based on the logic that we wrote, that just one of these elevators is going to turn on. And right now, because we haven't done anything to randomize or shuffle that array, it's just going to be the first one in the array. So it's probably going to be this one on the left here. However, you'll notice that 2 of them turn on. That's really weird. Why is that happening? So strange. Let's look at our logic to kind of figure out what might be going on here. If we go back in, this logic looks pretty clean. As you can see, I kind of toggled a breakpoint on here with F9 and toggled it on and off a couple times. Basically, what this does is when UE4 hits that blueprint node, it will pause the game, which allows you to kind of look at the state of your blueprint, see what's going on. I did see some debugging to kind of figure out why this wasn't working as anticipated. And the reason why is because we did not condition this on component begin overlap switch collider. And the player has a few weird kind of funky components on it that are causing the player to collide with this collider multiple times. So I noticed here, if we look at the default like player controller, first person character, it's got, if you look here, like this capsule component, which is colliding, but it's also got some things like this VR marker gun thing that collides and just a bunch of other stuff. It's kind of janky. So that's okay. We probably just want to condition this against the player's capsule component and make sure that that's the only thing turning the switch on. This behavior was masked by the door because the door was kind of a one-way thing and it was binary. It was off or on. However, now that we are like we only want these things to fire once, there's a number of different ways we can condition this. So let's look back at the switch here. There are a number of ways. So option number 1 would be for us to just add a do once node. This will get the correct behavior that we want. But option 2 would be for us to actually set a flag on this switch that determines whether or not it's already been used so that it can't be used a second time. So for example, we could set a local variable that's like, has switch been pressed? And that can just be a private variable. We don't actually need to expose that to anybody. And we could just kind of branch on that and say, if not, If not, has switch been pressed, then we want to actually run this logic. And then when we find something, we would like probably just, in addition to turning the elevator on, we would like set has switch been pressed to be true so that it doesn't get triggered multiple times. So I'm just going to kind of like, I think use this because this feels like kind of the cleanest solution to me. Writing code is a lot like creative writing. There's not always one perfect solution. It's kind of just whatever you feel like is best given what you're doing. There's very rarely like one specific way to implement something. So this is kind of just how I would solve this problem. But again, you can also use that do once node up front if you would prefer to do that. Okay, but so now we are turning on the first elevator in the array, and you can actually see that it will kind of be linear here. My guess is that it'll go left to right because that's the order that I copy pasted those elevators in. But if you copy and paste the switch like 3 times, and then you hit play, and you hit one switch at a time, you should see turns on one platform at a time. There we go. And basically it just went through the array, looped through, and just turned them on sequentially. There's no randomization yet. So if you wanted to create a world where you could actually just like linearly pair switches and controllers, you could, or switches and platforms rather, you could just leave it at this, but we actually want to turn on a random elevator. So that's the step that we're gonna do next. Let's go back to our blueprint. Okay, so all of this is working now to turn on one switch. However, we are missing the randomized kind of roguelike-y aspect of turning on an elevator and it being a little bit different every time, which is going to be tied to the homework assignment I'm going to give you this week. So let's go ahead and do that like randomization. Remember when I said that arrays are kind of like magic lists and you can do a bunch of cool stuff with them? Well, one of those things is that you can randomly shuffle an array. So let's get this out actors, and if you type in shuffle, yeah, all that does is see, shuffle, randomize the elements of an array. And that's really cool because what that means is that we're going to get a different order every time for the elevators that we turn on. So we have shuffled this array, and then when we actually get the first element of that array, it should be a random one every time. So let's back out here and confirm that that's true. Before we realized that like basically these switches would turn on the elevators in the order that they were created. They're just kind of like, you know, first one created gets priority. But now if we step on it, we should see, aha, a random elevator turns on for every switch that we push. So you'll see that second one doesn't even turn on at all. And then if we hit escape and we play again, we should see a different order this time. Yeah, so this time the third one turns on, then the second one, then the first one. And because of our dynamic reference getting at runtime, it's going to be different every single time. And it doesn't even matter how many of these elevators we have. We could have like, we could copy and paste it a million times and have like 8 elevators. And it does not matter because we have this magic list, this magic array of elevator references that we are looping through. That array can be basically infinity long. There's actually a real number cap on it, but it is so absurdly large that you don't have to worry about it. But now we have this nice system that can turn on random elevators and just kind of loops through them magically. So we have only just started to crack the surface of everything that we can do with arrays and dynamic references. Next time we'll be taking everything we learned today and we'll be building on that to build a little bit of a fun experiment where you can actually pick something up in the world and use that object on things in the world to dynamically change them at runtime. And what that's probably going to look like is the player being able to pick up a watering can and water flowers, and then those flowers will have a random chance of blooming or not. So for today, for your homework assignment, if you would like to get ready for that, what I recommend you do is take everything that you've learned today and see if you can use some of those array functions to do interesting things with switches turning on elevators. I'll post a few of the different types of things you might try with your homework assignment in the description for this video. But for now, you can also just use the randomization stuff we did today to create a pretty cool experience where the player actually has a slightly different experience going through different elevators every time. You can potentially create like a platforming game where they have to jump from elevator to elevator and then turn them on in a random order. Or you could potentially just create kind of like a gallery style game where the player turns on a random elevator, goes and sees something cool, and then sees something else that's interesting in a different part of the map, and they can only kind of experience that one switch and one elevator at a time. So there's a lot of different ways you could take this and play around with it. But next time we'll be building on this to do something even more exciting. So stay tuned. If you have any questions, as always, feel free to leave them below. I will do my best to answer them. And otherwise, see you next week. Thanks.